Before I begin, I want to clearly state that the content of this presentation is intended to be neutral and there is no inclination or affiliation to any content or information in my presentation to any organization or solution, including my own. The information shared is for information and education purpose only and should not be interpreted as an endorsement of any specific solution, product, service, or organization. While I've tried to use reliable and diverse sources, the inclusion of any component, content, examples, or reference should not be seen as an implicit endorsement or affiliation to the original authors or sources, if any. Some contents in these presentations were generated using with the assistance of artificial intelligence. Such illustrative representation may not convey accurate information. Any similarity in any content or information in the presentation is not intentional and is purely coincident. Users and viewers are advised to consult experts and research on their own before using any information or content shared in the presentation. My aim is to provide a neutral perspective.
Hello everyone and welcome to Cloud Native Gurugram's Summer Native Cube. I'm your host for today. Big thanks to all of them who registered. Thank you all for taking the time out for today's event. Let's jump right into the first session. First speaker is Tapas Nandi, solution architect at a reputed company and a passionate open source contributor. He's someone who thrives on customizing systems, implementing cutting edge solutions outside of tech. He's a biker, gamer, scuba diver, and lot more. Today he'll be speaking on Zero Trust AI, security first in Kubernetes deployment. Please welcome Tapas Nandi. Tapas, welcome.
Hello, everyone.
Over
A
to
very good
you.
afternoon. I hope I'm audible to everyone. Ali,
Yes,
am
you're
I
audible.
audible clearly?
Yes, audible.
Okay, and my screen is visible, right?
Yes, visible.
Thank you, Ali, for introducing me. My name is Tapas Ali. As Ali said, I work as a solution architect. My total years of experience in the industry is almost around 20 years. I've started back in 2005, and I started with Linux. I started with Red Hat Linux, and that's what was there amongst all of us. And Ubuntu and all came up, right? So today we are going to understand uh, a bit of a landscape of Kubernetes, security landscape in Kubernetes, and why security is important in a Kubernetes landscape. What are the impacts of AI in a Kubernetes landscape when we deploy AI workloads on a Kubernetes landscape? What are the implications of that, and why runtime security and zero trust securities? These are important in terms of organizational compliance and security, as well as from a personal perspective when we use AI in our day-to-day works, how the security in that landscape affects us, right? So we are going to indulge into that. Okay, so we'll have a quick introduction of the Kubernetes landscape, how it works, what are the complexities, what are the security challenges. We will go to the unique security challenges of a containerized landscape. We will see how these security challenges overlap with AI when deployed in Kubernetes. We will see the limitations of a traditional approach of a security. We'll understand the zero trust principles, and we will understand the importance of zero trust and runtime in an AI environment, right? If you have any questions, if you have any doubts, if you have any um, thoughts of what I'm sharing, please put your questions in the chat. You can ask me directly, and I will be glad to answer. Right. So to start with, we have seen the Kubernetes and its growth. Right. The like for developers, Kubernetes is like before even Kubernetes was there, we had containers. We have individual containers wherein developers could have deployed an application just directly on a container, and when he could have just built container, an application with all the libraries, with all the dependencies needed, and run on any of the devices, where the dependency on the bare metal device, dependency on the OS was not there, right? So it was very easy for the developers to quickly deploy an application, quickly change an application, whenever they are deploying, right? However, with the growing infrastructure of a container, it was difficult for them to maintain that infra. It was difficult for them to identify where their containers are running, where their applications are running, and that's where Kubernetes got introduced, right? But when Kubernetes got introduced, it brought its own challenges, right? In a Kubernetes world, the network architecture is completely abstract, right? You can't really see what how the networking is, what the networking components are within the Kubernetes infra. So because today, if I deploy an application in a Kubernetes architecture, in a Kubernetes cluster, uh, I the two applications for me can communicate easily. I don't really have to do any networking as such to make those two applications communicate with each other, right? So how does that happen? Because Kubernetes takes care of it by default. You don't have to do anything. It has its own, it is very simple. It is very beneficial for developers, for administrators, because they don't have to worry about networking. But on this, in the same time, it also brings in unique security challenges as to what is happening. You don't know how things are happening in a Kubernetes landscape, how containers are communicating with each other. You don't know, and when you don't know anything, it is difficult to control. It is difficult to basically, um, react to when issue comes up, right? So, and this was Kubernetes. Now when we come to AI, we know that today every organization is trying to use AI, right? May it be a car manufacturer, may it be insurance company, may it be a software company, everyone is trying to use AI in some form or another. And the best place to deploy an AI application is a Kubernetes landscape, right? So when we say I want to deploy an AI application, my application might be AI, my LLMs, my different components of the AI landscape would go as a Kubernetes workload. With the challenges of Kubernetes, AI, the challenges of AI, deploying AI on a Kubernetes landscape just adds on, right? So that is where we today look into how, what are these challenges, how we can mitigate these challenges using principles like zero trust security, runtime security, micro segmentation, and etc. Right? So as I said, right, containers increasing popularity just makes them more attractive to attackers. So anything which is popular, hackers and attackers, they try to exploit it. And when something is new, we don't know the entire infrastructure of or entire bifurcation of containers. So it is very easier for them, because they do the reverse engineering. They find out various components of the containers itself, and it is very easier for them, in the contrary to us, because we are just using it as a as a user. They are reverse engineering it. They're finding vulnerabilities within the dependencies, within the libraries, and that is where we are at the vulnerable end. So because we might, so when I'm developing an application, I pull images from git, docker hub. I pull images from open source endpoints, and basically I use those base image. I build my own application. I build package it with my own code, package it with my own libraries and dependencies. I make my own image and I push it to the cluster, right? What happens in this is we are missing completely on one, the base image that we downloaded. For say, I downloaded an Alpine Linux, so I don't know what vulnerabilities the Alpine Linux image would have, right? I'm not checking it. For me, what's important for a developer, what's important is an OS image that I pulled, and now I will compile my own development, own code into it, and I'll push it to my cluster. That's what my task is, and I'll do that, right? But what the attacker has done is might be has some planted some code into it itself, and once we use it to deploy our own application, we might be at the mercy to exploit that and access to our system, right? So that is one thing. Second thing is, containers itself are ephemeral, right? When in a Kubernetes cluster, when we deploy a container, as we all know, right, when the container comes up, it comes up with a new identity, new IP address, new host name. The only task for it is to execute the task which we have given. It'll execute it, and after a certain time it will die, and it will spin up a new container. That's what replica said, and that's what deployments does for us. And whenever they are coming up, they will come up with a new identity, new IP address. We can specify the IP address in certain form, but it would be a lot of a overhead for an administrator in a landscape where I have thousands of Kubernetes cluster, millions of containers running. For me to specify a IP address, a host name for each and every containers is really difficult, right? So with this dynamic nature, what we need is a dynamic security. Dynamic security does not come only with a security appliance, right? Dynamic security comes with a layered security approach. So each and every layer of my development, each and every layer of my application deployment stage should be secure. How do we do that, right? This is a small illustration of all the possible attack surfaces that a Kubernetes has, right? So there are OS packages, right? So all the OS packages we have, whatever OS we are using as a base image for deploying our Kubernetes cluster, they have vulnerabilities. So that can be catered easily with some scanning, with some antivirus and anti-malware tools which we deploy. That can be catered. Then there are components of the Kubernetes cluster itself. When we are deploying Kubernetes cluster, they have their own component that can introduce a lot of vulnerabilities. Then we have the exploits from within the containers, right? So within the container, there are security breaches, there are malware attacks, there are insider threats, there are third-party dependencies, encryption challenges, orchestration attacks, network threats, privilege escalation. All these comes as a part of a containerized deployment. So you can see that how the OS deployment is different, how the container deployment, how it exposes the surface, attack surface for a attacker to, they can find out more vulnerabilities. They have more playground to play on when we are using a containerized landscape, right? So the now this was from a Kubernetes perspective, container perspective. Now let's say we are deploying an AI application on top of a Kubernetes cluster, right? So Kubernetes unique, like Kubernetes itself is dynamic and distributed, as we just saw, microservice architectures, ephemeral containers, and complex networking. Now that itself is a challenge for deploying an AI architecture on top of a Kubernetes landscape. Plus, we have model integrity, like so ensuring the authenticity and trustworthiness of AI models. That is our responsibility because we are using an AI application. Next is the supply chain vulnerability. So when I say that I am pulling an image from Docker Hub, I'm building my own image. That is my supply chain, right? I need to be able to secure that supply chain in some form so that I am at least secure from known vulnerabilities, like some kind of code scanning, some kind of image scanning. I need to do that because if I don't do that, then apart from unknown vulnerabilities, I'm also inviting all the known vulnerabilities into my cluster, which is not secure from a perspective of organization, not secure from a perspective of individual, not secure from a perspective of compliance as a whole. So what happens when my organization, I'm running an suppose I'm running a car manufacturing company, and I'm running AI to run some of my car models, right? So if I'm building an image and a attacker tries to, or attacker gains access to my model, and my integrity is compromised, and that same model is pushed to some of the cars, and what will happen is when the driver relies on that AI, when the user relies on that AI, it could lead to accidents, it could lead to reputational loss of my company. The individual itself is suffering because of the accident, but what happens is the reputation of the company, the revenue of the company is at stake. right? When the reputation is at stake, that one accident can lead to basically disadvantage or effect to the entire company as a whole for years to come. That one incident can affect the company for many years, many models, double triple checks will come into picture, the compliance will be at stake, all these things will come into picture from that one incident. A lot of incidents have happened in the past, with Kubernetes landscape being compromised. And we can find out these use cases, research papers on the internet. I don't have to explain it over here, but that is what the truth is, right? So supply chain vulnerabilities is, no, tackling the supply chain vulnerability, tackling the model integrity is utmost important in a Kubernetes landscape, right? Then we have access control and authentication. We need to provide only the required access to the AI workload. We know that AI does its task, whatever is required from it. It will pick up from links, from PDFs, from documents. It will basically execute the task. But what is important is limiting that scope to only the required workloads, required APIs, required resource and underlying infrastructure, so that a granular control can be ensured only to authorized entities that can access the AI resource, right? So this is an illustration of a traditional security. Now we'll see how and why traditional security model is inefficient, or I would not say inefficient, but is limited in the scope how it operates, right? So this is a in a Kubernetes cluster, right? So there are containers, there are pods, two containers, and we have two pods. Um, the internet is there. So on top it's the outside the cluster, and the bottom side is within the cluster, right? So you see, this is the east west traffic. In a traditional Kubernetes world, only the north south traffic which is there is catered to. So I have a perimeter device, I have a firewall, right? My firewall will only be able to see, might only be able to see what is going outside my cluster and what is coming inside my cluster, right? So Narendra has a question. I think, which base container image would you recommend for AI application to keep image size minimal? So Narendra, it depends on what kind of AI application you're running. Every AI application has a different requirement, right? And from a perspective of application, you would choose your OS, or you would choose your base container image, you would choose even your Kubernetes cluster and the LLMs. So you need to check what LLMs are supported by which kind of Kubernetes distribution, which kind of base container image. So all this depends on what kind of application do you want to run, because AI itself is a big word. AI itself is a small, chat mechanism can also be called as, an AI for me, right? Because we are using chat GPT, we are using a lot of chat applications, right? So again, Gen AI applications, even Gen AI applications has a large category. Not all Gen AI application will be suitable for a similar kind of infrastructure. So it depends on what kind of Gen AI application you're using. So we can take that later, because we are deeping down. We are driving deep into what AI application it is. The context of today's talk is basically the security of an overall AI model, right? You can reach out to me. We can discuss this later, right? So where was I? Okay. So limitation of traditional security model, right? So as you can see, the north-south traffic which is there, that is the traffic which is flowing outside my Kubernetes cluster and coming within my Kubernetes cluster. Now, suppose I have a perimeter device and like a firewall, or an OS firewall like an IP tables, right? So my how does IP tables operate is, I have to put an IP in, with a rule whether I have to reject it or not, with a port, whether it's allowed it or not, and then it will basically block or allow the IP based on the rule that I have set. Now imagine preparing a IP tables rule for thousands of containers, and with the fact that I have to keep on changing the IP and the port, so that it reflects the changes in my Kubernetes cluster. It's nearly impossible for me to do some kind of or make some kind of firewall or IP tables that can reflect these kind of challenges. It's nearly impossible. And if at all somehow I am still able to do it, my cluster would be basically impractical to operate with in real world, right? So all those things come into picture. And from a form factor perspective, it is impossible for me to shrink that IP tables and to a container landscape and bring it onto the Kubernetes cluster to protect my application. Now if I consider the firewall level, then my firewall is not able to see what is going inside my cluster, what is happening within my pods, right? So when it is not able to see something, it will not be able to protect. Now as I said, right, my images are vulnerable. My images might be vulnerable, not are vulnerable, might be vulnerable. So that vulnerable image can basically speak to each other, and the vulnerability from one image can spread to other. My attacker can basically exploit that vulnerability which is happening within the container landscape and gain access to my cluster, gain access to my data, right? Which is very much doable, right? How do we protect that? So we need something which is basically dynamic in nature. We need something that can basically see the east west traffic, protect me against these east west traffic, be a that can basically do dynamic behavioral learning and protect me from the east west can vulnerabilities that if there is any, right? This brings us to the principle of zero trust, right? So zero trust itself is a wide word, but it has a lot of small definitions within it, like principle of least privileges, microsegmentation, never trust always verify. These kind of things make up the zero trust principles, right? So in when we are deploying so there are a lot of applications. I would not go into a specific solution over here because we are representing the CNCF open source forum, and I don't want to, incline to a specific solution. So I would not name or incline towards the specific solution. But there are a lot of solutions in the market that helps you scan the code, that helps you implement zero trust and runtime principles, right? And you can easily find out what is suitable for you, what is the best practice for your environment, right? So that was to Hariom Chaudhary, who has asked for a question for vulnerability, which app should be used, right? So the principle of least privilege is basically limiting the access to resources based on specific needs. So if my AI application or AI, a part of AI application needs only an access to basically, um, you know, uh, uh, one single library or one single resource, I will just give or one single pod basically. So I will just give access to that pod, to that AI resource, and that's pretty much it. I would not be giving it a whole cluster wide access, so that it might not be misusing it. But why would I give that? Tomorrow if an attacker is able to gain access to my cluster, then he can easily misuse that access and increase the damage range, right? That is why principle of least privilege is utmost important. Then we have micro segmentation, right? So micro segmentation is basically compartmentalization, as I call. So Kubernetes world gives us the option, gives us the feasibility of segmenting things, right? I can have one big application. I can basically break it down into modules, break it down into segments, and make it operate as a whole. But when I want to basically change or enhance or introduce some new feature into that one single part of the application, I can just make changes to that, and um, I don't have to touch the entire application. With this micro segmentation principle, I can also implement this principle into isolating AI workloads and infrastructure components to minimize the attack surface. So that is what we need to keep in mind when we are basically developing our AI applications, deploying our AI application. This is what we need to keep in mind. Then we have never trust, always verify. We all have been to airports, right? So in airport, even if you're a visitor, you need to pass through certain security checks, right? Even if you are a celebrity, even if you are a politician, you need to pass through certain security check. The same principle you can, visualize the same principle in a Kubernetes cluster, right? Implementing strong identity and access management for users and services using, service accounts, using supply chain security, using runtime security. It's very important so that all the components which is running inside your Kubernetes cluster is authorized to do so, authorized to do what it is supposed to do so, right? So may it be leveraging Kubernetes RBAC, may it be leveraging service accounts, or integrated authentication and authorization mechanisms. So these are some things that you need to take care of when you're deploying Kubernetes, deploying AI workloads in a Kubernetes landscape, right? Why is it important to you know secure our AI workload? Like, we think that it might be secure. We think that it might be, it's AI. It's the world wherein all our information we are getting is so enhanced. So security should also be automated. But it's not true. If even when we are using ChatGPT, we are giving an information to ChatGPT in certain form. It's used to train some models, right? Um, uh, Suppose I am writing information about Tapas Nandi, but when it's answering to me based on certain data, certain algorithms, certain models that it has already been trained, right? These models are used to train these information is used to train the models as a whole. Now that information can be useful to you, but that information can also be useful to someone else. It might not be useful for many people, but for an attacker, for a person who is basically trying to find out that personal identifying information, for that person this information will be useful, right? So the models are trained on these kind of wide data. They have the PII, they get information about the financial things, the intellectual property. Zero trust ensures that only authorized people can access this data. That is why zero trust is important. Then we have maintaining the model integrity. We need, so integrity in terms of as a whole, we need to be truthful, we need to be know our limits. This is what integrity means, and same integrity principle can be applied to models, right? So when AI models themselves are very valuable assets, zero trust helps prevent unauthorized modification or tampering with the models, right? Ensuring zero system reliability. AI systems often drive critical functions. Zero trust minimizes the risk of attacks that could disrupt the systems. In terms of compliance and regulations, when we are deploying AI, when we are deploying Kubernetes clusters within the organizations, they have certain compliance, certain regulations to adhere to. Zero trust principles, runtime security basically helps the administrators to adhere to these compliances, adhere to these kind of regulations that their organizations are supposed to follow. So that is where zero trust is important for AI, right? There is something else called as runtime security. Zero trust is one thing, runtime is another. When we spoke earlier about the supply chain security, the securing the models, the securing the base container images, securing the the deployment channel, right? The SDA, software delivery life cycle, right? That is the supply chain phase. Zero trust is one more, and then we have the runtime security. Runtime security can be clubbed with zero trust and implemented as a whole. But definition of runtime security basically is um, uh, you know is a bit different, wherein a runtime security helps you actively protect your cluster, like when it is running, right? So say I am running an application of Apache, right? My Apache is running, basically it has multiple components within it. One of my component, now it is not necessary that my software delivery lifecycle, when I scanned my SDLC and my image is secure and I have deployed it in my Kubernetes cluster, I have implemented layered security as well. But there are certain vulnerabilities which were not known when I was deploying the application. Because it was not known, its signature was not formed. Because its signature was not formed, it was not pushed to any of my scanning tool. Because it was not push to any of my scanning tool, none of my scanning tools were able to detect any kind of such vulnerabilities because it was not there at that point in time. However, going further, there is a vulnerability in my suppose Apache container which an attacker is able to exploit. It's a 0 day kind of attack, right? How would my I protect my cluster? How would I protect my application in that scenario? That is where runtime security comes into picture. Runtime combined with zero trust will limit the attack range to that container itself. Not only limit, it will prevent the execution of basically that attack altogether, right? So what happens is I am allowing only a certain process to run within my Kubernetes container, within my container of Apache, whatever it is, right? Whatever I'm running. When a second application tries to get executed, right? So suppose I have allowed slash bin slash Apache 2 to basically run on my container. Now slash bin slash sh xyz tries to execute in my container. My runtime security will prevent it from executing. This will prevent my 0 day exploitation. This will prevent any execution of any kind of attack, even if the vulnerability was not known when I had deployed the application. This is where runtime security is important. It takes off the overhead for you to manage the exploit because it is not letting the exploit to happen in the first place. So there are two principles that you have basically combined together. One is segmentation, zero trust, only provide necessary access to your container, and second is runtime security, wherein you have basically stopped or stopped the execution of anything which is not allowed in a cluster. That is called runtime security. So runtime security is like, it's a security guard always on duty, like I said, always. It depends, it works on the principle of behavioral monitoring. It will basically know what is running inside the cluster. It will prepare some charts, prepare some security policies on its own dynamically, automate in an automated behavior, not manually. And basically it will only allow what you have allowed, what is written in that policy. Apart from that, everything will be blocked, right? So if a threat is detected, runtime security can block it or prevent it from causing any harm. The importance, like I said, it's the last line of defense against attacks that bypasses traditional security measures. It monitors the application behavior in real time to detect and block malicious activity. It's essential for protecting AI workloads from 0 day exploits. Not only AI workloads but any kind of workloads, I would say, because my SDLC may not, as I said, might not have the information of a 0 day vulnerability kind of thing because it was not detected or not the signatures for that might have not been formed or pushed into my security scanning tool at that point in time. So that is where my runtime security comes into picture, and it enables continuous monitoring and compliance for dynamic Kubernetes environment. So that was from my side. If you have any questions, please ask. I hope the session was helped you to gain a bit more understanding into why zero trust and runtime is important in Kubernetes, in not only in AI workload but also in a Kubernetes landscape as a whole. I was able to finish on time. Wow.
Well, that
Ali,
was
over to
lot
you.
of yes. Okay. I do have one question. Like,
Yeah,
is
sure.
runtime security essential for every type of application, or mostly on for production grade systems with external exposure?
So, see, we have to understand how runtime security works, right? Runtime security is it's always running, but it gets activated only when something tries to run in a Kubernetes. So, suppose you are running an Apache container, right? You are have a Kubernetes cluster. You're running a Apache container. Now, you might have scanned the Apache base container image, whatever it is, using your scanning tools when it before deploying. You might have also scanned the registry where the image is. You might have also scanned the image before deploying, right? All this security you have implemented, but these tools which is scanning, they only work on the principle of basically known vulnerabilities. There is something called as known vulnerability, there's something called as unknown vulnerability, right? So when you known vulnerability works on the basis of signatures. So today, if there is a vulnerability which has come up, so all the organizations, all the security firms will basically try to make a a signature of it and then push it to their relevant security tools, so that their tools are able to identify that vulnerability based on these signatures. But runtime security, it doesn't depend on the signature. It is depending on what you have allowed. So runtime security, you have already secured your. That's where I said, right, layered security approach is very important in the Kubernetes environment. So this is your layered security. You have implemented supply chain scanning. You have implemented registry scanning. You have implemented admission controls that only scanned images should be deployed onto your infrastructure. All these you have implemented. But if there is something that is not known, how would you prevent that from damaging your cluster or attacking? How would you prevent the attacker from executing that exploit in your cluster? That is where runtime comes into picture. It is important from a perspective of protecting you from any kind of unknown vulnerability in day two.
Now we are open to question and answer session. Guys, if anyone has any questions, you can drop your questions in the chat box and the person will answer your queries. Okay, there's one
Narendra,
question
there
from
is
Naren. Yes.
Narendra, using Podman instead of Docker, right? These are both with respect to security, we need to check they are engines, right? So you we need to check what kind of I can't answer that. There is no straightforward answer to that. Instead of, it depends on your use case, it depends on what Podman gives, it depends on what Docker gives. You have to check the security articles provided by these tools, and then we need to figure out what is acceptable, what is not. But Narendra,
Okay.
so when you are using
Name
Docker, when
remember.
you Narendra, when you're using Docker, when you're using Podman, you are basically using these engines. It also depends on the Kubernetes distribution that you will be using, because Kubernetes distribution have a dependency of some container engine underlying, right? So it depends on what kind of Kubernetes cluster you will be using, what kind of some Kubernetes cluster, they use container D as well, right? Some Kubernetes distribution might be using Rocket or Cryo. All the kinds of engine in the Kubernetes cluster use. So it depends on what Kubernetes cluster you would be using. The question to that also, like which container Kubernetes cluster, depends on your application as to, and the requirement of performance, requirement of regulations, requirement of hardened Kubernetes distributions. All these comes into picture when you are selecting basically a Kubernetes distribution.
I hope Naren has got his question. Is if anyone has any other question, you can question in the chat box. I guess that's it. Thank you, Tapas, for coming and giving your time to CNCG Gurgaon. That was really fascinating deep dive into securing Kubernetes with zero trust. Thank you once again.